All right, so here's the quick review of evaluating nth roots and rational exponents. This part right here, this A, goes underneath the radical. Okay, so you have negative 216 here. This n is your index. So that means the cube root of negative 216. Once you have it set up, just do this on your calculator. You're going to go to math. I think it's number 4 for cube root. And then just type in the number, and you get negative 6. All right, so same thing here. A is 81. So underneath the radical, you put 81, your index is 4. So this time, you're going to have to change this to a 4 in your calculator. Do the 4th root of 81, 3. Okay, you can check the answer key for the next two. Oh, the top part of this up here, notice. If your exponent is even, you get 2 answers. We did that with square roots, plus or minus. If your exponent is odd, you only get 1 answer. So if the number underneath is negative, your answer is going to be negative. If it's 0, it's going to just be 0. If it's positive, it's positive. There's no plus or minus there. So keep that in mind when we go to solve. But first is rewriting rational exponents. So remember your exponent rules. If you pull out this numerator, the m, then you're left with 1 over n as your exponent. It can be rewritten as a radical by keeping m as the exponent here, and then your fraction actually becomes the index of your radical. Okay. The other thing here is if it's negative, it moves to the bottom. So let's look at one here. You can start by using your calculator. So I'm not taking your calculators. I would put in your calculator 16 to the 3 halves. And you should get 64. That way you can kind of work backwards and make sure you're doing it correctly. So first is a rational exponent. Exactly how it sounds. The exponent should be a ratio. So the base still stays 16. Remember we said the numerator, this part here, comes to the outside. And then your denominator stays. So now you just have a 1/2 because the 3 came out. Okay? If you write this as a radical, well, then you should have a root, a radical, right? The exponent is 1/2, which means whatever's in the denominator, that's actually your index. You don't have to write if it's a square root. You don't have to write the root. But then the same thing, 16, and your exponent is 3. I would double check on the calculator that these are all 64, because if they're not, we did something wrong. When you put 32 to the negative 3/5, well, I know negative means fraction, so it is going to be a, well, if you first do it in a calculator, it's going to be a decimal, like 1.25, but that is 1 over 8, right? So as we're doing these, we want to just double check that we're doing it correctly. So, rational exponent, exactly how it sounds. Ratio should be in the exponent. So your base is 32. Pull out the negative 3. You're left with 1 over 5. So then for the radical one, exactly how it sounds. You should have a radical. Your number underneath is still 32. The exponent still comes out. It's negative 3. And this time, since the denominator is 5, that means your index here is 5. You could check this on the calculator by doing the 5th root of 32 and then raising that to the negative 3rd power. You'll still get 1/8. So because they're all numbers, you can check them. All right. These are your turn, so you can try them and then check the answer key on the portal if you don't have the answers. The next section here was solve. If I see solve, that means I need to have an answer of x equals. Okay? So just like when we did square roots, isolate the term being squared and then take the whatever root you need to get it by itself. Okay? So first things first, divide by 4. You get x to the 5th equals 32. To get rid of the 5 in the exponent, you take the 5th root of both sides. And then on your calculator, the 5th root of 32 is 2. Okay, look at this one. This x minus the root of the 4th is being raised to the power, so it's already by itself. To get rid of the exponent, you have to do the 4th root of both sides. So you're left with x minus 3. Since it's an even root, you should put plus or minus in front. X still isn't alone, you have to add 3. So x equals 3 plus or minus the 4th root of 21. Okay? This one, x to the 5th, is being raised to the power, so you need to get rid of the 1/2. Multiply both sides by 2, right? The 1/2 and the 2 cancel. You're left with x to the 5th. 512 times 2 is 1024. To get rid of the exponent 5, take the 5th root of both sides. Using your calculator, you should get x equals 4. All right, looking down at C, we'll do these real quick. The whole thing, x to the 5th, is being raised to the power. So you can just go straight to take the 4th root of both sides. In your calculator, when you do the 4th root of 16, you get 2, but because it's an even root, plus or minus. So now I'm going to subtract 5 on both sides, but I have to do it both ways, right? You have 2 minus 5, which is negative 3. You also have negative 2 minus 5, which is negative 7. Okay? So remember, because it was an even exponent, you have a plus or a minus. All right, look at D. First off, you notice it's a square, right? So it's going to be even exponent. Divide both sides by 3 first to get x squared alone. 108 divided by 3 is 36. Square root, x equals, it's an even exponent, so I'm going to put in my plus or minus 6. Okay, this one's a cube root. So cube root both sides first because x minus 2 is all in parentheses. Because it's a cube root, I don't need a plus or a minus. I need to get x alone, so you add 2. 2 plus cube root, negative 14. This section is using the properties of exponents, so I'm not asking you for the answer. I'm asking you to use the properties above, okay? But you should remember them from when we did properties before. If you're multiplying, you have to add your exponents. So the base stays the same, and then you have 1/4 plus 1/2. Now, how you do 1/4 plus 1/2, I don't care. If you need a calculator, that's fine. But otherwise, you would multiply top and bottom by 2, so it's really 2/4. So 1/4 plus 2/4, 3/4. If you don't know how to add fractions, put in your calculator 1/4 plus 1/2, and then just make it a math fraction, okay? I'm really testing here, like, do you know the properties? So this property in number 2, if you have an exponent outside, you multiply it inside, right? So 6, and then 1/2 times 3, 3/2. That's all. Okay? Same thing here. Do you know the properties? You're distributing it to all the things inside. So all I need you to do is just write this. If you want to keep going and evaluate, you can, but that's not what I'm asking you to do here. Just use the properties, okay? This says no negatives, so you have to move it to the bottom. And when you do that, the exponent becomes positive, and you're done. If I'm dividing, you subtract. So 3/4 minus 1/4. 3 minus 1 is 2. 2/4 is actually just 1/2. Okay? And then last, just like the one above it, distribute the exponent inside, and you're done. Okay, so again, I'm not asking you to evaluate, just apply the properties. All right, this one is using the properties to simplify. So up here we have, if they're already being multiplied under 1, you can split them into 2. Same thing with division. If they're being divided under 1, you can split them into 2, and vice versa. So if I look here, I have 12 times 18. I'm going to write it under 1 square root. 12 times 18 is 216. The cube root of 216 is 6, so I'm done. This one, 80, I can't do the 4th root of 80. I can't do the 4th root of 5. So I'm going to do 4th root 80 divided by 5, which is 16. And the 4th root of 16 is 2. Okay? Here, it doesn't help me to use either of the properties. I got to think back to when we did square roots. It says you have to rationalize the denominator. In order to do that, you multiply top and bottom by whatever radical you have on bottom. Since 5 and 2 are both under a square root, I can multiply them together. Root 2 and root 2 are both under a square root. I can multiply them together. The square root of 10 doesn't simplify, but the square root of 4 does. It's just 2. All right, in number 4, I have 96 divided by 3. Rather than separating it like in number 2, I'm going to actually simplify that, because 96 divided by 3 is 32, and the fifth root of 32 is just 2. Okay, I noticed right away, because I know my cube roots, that these are both perfect cubes. So I'm going to simplify them first, but you have a calculator, you can multiply them first if you want. The cube root of 125 is 5. The cube root of 8 is 2. 5 times 2 is 10. All right, this one, multiply on top first. Root 2 times root 8 is root 16, and I still have root 5 on bottom. The square root of 16 is 4, so 4 root 5. I can't have a root 5 on bottom, so multiply on top and bottom by root 5, and then you have 4 root 5 over 5. Okay, moving on. Then we have some more like this, where you have to simplify, right? So I have one number under the cube root. I'm going to break it up into 2 things that multiply to 135. So go through all of your factors. You've got like, 3 and 45, 5 and 27, 9 and 15. And I'm looking for ones that are a perfect cube. So I try, and I do cube root of 3, doesn't work. Cube root of 45 doesn't work. Cube root of 5 doesn't work, but the cube root of 27 does. So those are the 2 I'm going to use. I put the perfect cube first, and then the cube root of 27 is 3. The other one does not simplify, so it stays under the radical. Okay? When adding, just like with all polynomials, you can only add things with the same last name, right? So they both have the last name of 4th root 10. So now, whatever, it doesn't matter what the last name is. If it matches, just add or subtract the numbers out in front. So 1 plus 7 is 8, and they are still 4th root 10. So now I have 8 4th roots 10, right? So here, don't get confused by the notation. They match, right? So that's all I care about. So now just add 2 and 10 is 12. And then you can leave it 8 to the 1/5. Or if you prefer to rewrite it as a radical, 5th root of 8. Okay, so you're just applying the properties here. Last names are the same, so just combine the numbers out in front. In this case, it's a minus, right? So 3 minus 1 is 2. 2 cube root 2. Here we are starting to cycle back to where we were before. We're dividing. So 250 divided by 2 is 125. Actually, the 125 is a perfect cube. It's just 5. So this is more just like the previous problem, but rather than number 1. You just have to practice and do it. These do not have the same last name, so I cannot do anything with them unless 40 simplifies. So I go through all my factors of 40. I've got, 2 and 20, 4 and 10, 5 and 8, and I'm starting to know what my cube roots are. So I notice that there's an 8, and I know that's a perfect cube, so that's the one I'm going to use. 8 and 5. What is the cube root of 8? 2. And then I have a cube root 5. The other key is, if this one is a cube root 5, you want to try and make the other one also a cube root 5, right? So just keep that in mind. When I add these together, it's like there's a 1 out in front. So I have 3 cube roots 5. And we're done. Okay, so then it gets a little bit harder when we have variables underneath. So just like before, we always want to try and break it up into 2 square roots, right? And the first radical is where I always put my perfect cubes. So whether it was or squares, whatever, right? Whatever simplifies there. So we're going to break it into 2 square roots. This first one is everything that you say, yes, it can be simplified. The second one is no. Okay? So just ask yourself, can you take the square root of 49? Okay, so since we can do the square root of 49, it goes in the yes square root. I can do the square root of x squared, so that goes in the yes. I cannot do y to the 5th, though. So I have to break it up into y4 and y1. I didn't leave enough space. Z6, I can do 6 divided by 2. Now, since this is my yes square root, what is the square root of 49? 7. What is the square root of x squared? X. Square root of y to the 4th, y squared. Square root z6, z3. This that you're left over with stays on the end. And then you're done. In this one, we're looking for perfect cubes. So we're still going to separate it into 2 cube roots, and then you ask, can I do the cube root of negative 27? Yes, you can. So it goes in the first bracket. Then you look at your x to the 7th. I can't do 7 divided by 3, so I have to break it up into something that is divisible by 3, like 6, and then one that's not divisible by 3, 1. And then you do the same thing with the y. It's y cubed already. So I'm going to leave it in the first cube root. Z squared, the 2 is less than 3, so it stays on the top. Then you simplify the first radical. So the cube root of negative 27 is negative 3. And then when I do the cube root of x to the 6th, it's really just 6 divided by 3x squared. And then y cubed, 3 divided by 3 is just y. All this other stuff stays underneath the radical. So we leave it like that, okay? If you look at this one, this is a square root. So I'm looking for everything that's, well, first, the square root of 64 I can do. And now I'm looking to see, do the exponents divide? A4 divided by 2, yes. B, I can't do that. C3, I can't do that, but I need to separate it to C squared and C1. Now the first square root, everything simplifies. The square root of 64 is 8. A to the 4th square rooted is a squared. C squared is just C. And then underneath the radical we have BC. So then that one is done. This is a 5th root. So negative 32 I can take the 5th root of. F6, I can't do 6 divided by 5, so I'm going to rewrite it as F5. F1, G5 I can do, and 2 is less than 5, so H2 goes in the second one. The 5th root of negative 32 is negative 2. 5th root of f to the 5th is f, and then G5 becomes G, and this stuff stays under the 5th root. Okay. The only thing we added on the back was just multiplying. So we don't have the first one on here, but I'll just skip around here. These I want to write under 1 cube root. So first off, 27 and 5 is 135. A times a to the 4th is a to the 5th. B cubed and B cubed and B1 is B4. And then, I don't know how this stuff is getting here. So that's the first step. Then you want to break it up into 2 cube roots, right? So 135 you can't take the cube root of. So I'm going to break it up into 27 and 5 because I can take the cube root of 27, right? A5, I can't do 5 divided by 3. So I'm going to rewrite that as A3 and A2. B4, I can't do 4 divided by 3, so I need to rewrite that as B3, and then you're left over with B1. The cube root of 27 is 3. Cube root of A cubed is A. Cube root of B cubed is B. And then this stuff is still stuck under the square root. Okay? Let's just look at one more. So you can look at 3 on the notes key, but I'll do one more here. All of this is going to be under the 4th root. 64 divided by 2, 32. X10 divided by X, X9. And then you've got your Y10, right? So I need to break it up into 2 4th roots. Right now, can I do the 4th root of 32? No. So I go through all the factors. I've got what? 4 and 8, 16 and 2. 4 is a square root, but it's not a 4th root, so I need 16. So 16 and 2. X9 would be X8, X1. Y10 would be Y8, Y2. Now I'm ready to simplify the first radical. The 4th root of 16 is 2. 8 divided by 4 is 2, Y2. And then all this stuff still under the square root. Or sorry, 4th root. Okay? So there's everything up that's going to be on your quiz.